So hi guys, welcome to the channel. So actually I have gave the Atcoder contest and uh, last note. Okay, there is Atcoder contest on Sunday also. Grand contest. Okay. So yeah, I gave this contest and there is a quite a problem which I stuck during like my submissions, which is this problem number D. So yeah, in this video, I'm going to discuss about this problem D, what this problem actually means. And for me, if you ask, like this problem is quite easy, as I can say, but at the time of contest, like I really can't just optimize the solution. So let's read the problem first. So there is an encross and grid. Takashi wants to color each cell black or white so that all the following conditions are satisfied. The first condition is for every row, the following condition hold. There exists integer I such that I ranges from 0 to n, such that the leftmost I are colored black and the rest are colored white. So let me use a pen. So the first condition hold like for any I, if there is a grid, let me create a small 4 cross 4 grid. Okay, so it's n cross n grid. So let me go with the 4 cross 4 grid. Yeah, so what is mean, like if currently my eye is there, right? So everything left to it must be colored black while the rest of my grid is colored white. The first rule or condition is this. The second condition is for every column the following condition hold. There exists an integer I such that I ranges from 0 to n, such that the topmost I cells are colored black and the rest are colored white. The second condition is that every topmost cell from here, like this whole part, must be colored black, while the rest of the cells are colored white. So yeah, this is the problem. And out of enclosed cells, m of them are already been colored. Among them, the ith one is at the z ith row from the top and y ith column from the left. So basically means that uh, before giving us the question, they have already colored some of the cells. Right. So like for example, if I give you for this test case, I must say one cross um one is colored black, for example. Then its color black means that every cell in its left are also colored black and every cell above this one cross one is also colored black. Right. So determine whether he can color the remaining n square minus m's. Like there is a whole n cross n grid, so there are n square cells, and about of which the m has been colored. So we have to check like the rest uncolored matches or satisfy the condition that or no. The condition is simple that if it's something is being black, then its left must be black and its above must be black. Right. So if we see into the question becomes for any n cross n grid, for any n cross n grid, uh, okay, the question become really simple. Like for any n cross n grid, if this is black, it means this whole part must be black, right? From this to this whole part must be black. So if I got any white between it, then I would say my condition is not satisfied because every left part and top part must be black. So yeah, that's the whole question is about. So like we have to determine, like we can create a grid something like that. Like for any cell, this part is fully black and rest part is fully white. So there is an example also. like this. Here we 3 2 are white, 3 and 2 are white. So 1 2 3 second 2 is white. 1 4 1 is black. 4 1 is black. And its whole row is going to black. Its whole above column is going to black, and left part is also going to black. And if this is black, now again this is black, then the next condition is 1 3. So for that, for him also, this whole going to be black, and this is going to black. So at the end I just want that my white, the white color doesn't come between my black. So like if this is also being blacked, and this is also being blacked, and this is whole also being blacked, right? So if my white came between my blacks, then the condition is dissatisfied. So that's where I have to return no, else I have to return yes. So the approaches of this problem is like really kind of simple, I can say. So firstly, when I approach this question during contest, I uses a of and square solution, in which what I did that I make pairs of black and white colors. So where the black color represents, I stored indexes of black and white separately. Then I iterate like my white corresponding to the whole blacks. Actually, I trade my blacks corresponding to whole white, and I check the condition that at any certain point, if my white come in between my black, like there is only two conditions when this whole thing is dissatisfied. The first condition is like if there is ij which are of black, which are of color black, pardon for my writing, and if any another cell which is of color white, whose indexes are, let's assume, a and b, and if my a is less than is equals to I, means like if my I hold here rows, so if my a is less than is equals to I, right, my a come to this side to my black, then as we know the condition one said everything in the left side must be black, so that's a dissatisfied condition. And that condition must be if my b is less than or is equals to j, right? So this is if this is black, and for assume uh, this is also coming black, this is coming white, not this one, and this is coming white, right? So yeah, again my condition is getting dissatisfied because everything above top must be black. So yeah, a white cannot become between black. So this is the two failing conditions. So for the code part, what I did at that time, I just run an O-Fenster solution, and later on I try to optimize it, but I can't during the contest. My test cases are failing for some 5 test cases. But later on when I checked the solution, I got a pretty much easy implementation. The implementation goes like, firstly, we store everything like I, J, and color. Then we sort our array according to our row. Now, what I'm doing at that time is like storing the things based on like I'm sorting the things at that time also, but I'm iterating again and again for every black part. So that's not a good thing. So what I did in this condition, instead of iterating for black and white separately, why not to combine both of them? So we combined both of them, sorted accordingly through the row. Then the condition we check is that now if my white, we are taking the count of smallest yth index, because we know that our whole enclosure matrix is sorted according to rows colored. M colored matrix sorted according to rows. So what I'm taking out is of Y, the column part. So at any point of time, if my W column is less than my black column, then I can say that. So the condition goes like the condition goes like for any point here, if my W comes here at any column which is less than it, then this whole part must be black, right? But there is a white mole in there, so that dissatisfies that conditions. So hence we just break our code and return y there. So let's check the submission. So yeah, here is the submission. I sorted it and maintaining minimum for the yth part and just check the condition. If my extra second is equal to black and it is greater than my column, then just return cout no and just return it else cout yes. So this is the whole code for this program. Thanks.